So the last thing you need to know in this course is how to take a sine wave and put it through some translations. So we've got the basic formula here. It looks a lot like all the other formulas we've used. It's just a sine one. So this is the function. The thing outside the function is the vertical stretch. The number multiplying inside the function is the horizontal stretch. This is the horizontal translation, and this is the vertical translation. Now, a sine wave is very specific on the attributes of the graph, and so that helps us because we can get really picky with what this is. This, being the vertical stretch, will be the amplitude of the wave. It's supposed to equal 1, but if there's a number here, it's going to equal this number instead because we're going to be multiplying that number by 1, so it's a straight read. B is a little trickier because this is actually this horizontal stretch, so it affects the period of the wave. So this one affects the period of the wave, and just like before, we divide by B. So in this case, we're going to have 2 pi, which is the usual period of a sine graph, divided by B, and that's going to be our new period. Now these ones are just your basic shift left or right. So those ones, and D is your up or down. Now, because a sine wave is so very specific in its shape, there's a couple of things that we can rely on. We can rely on the fact that I can apply this to the midline of the graph. Doesn't matter whether it gets stretched or anything, it's still going to have a midline, and that application is going to be able to be used straight to the midline. So maybe we'll go use on midline of the graph. This one's pretty basic. It's usually going to be in terms of pi, and it just shifts it one way or the other. And we've already talked about the other two, so what we're going to do is apply this to the equation that they gave us for example 1. Now, for example 1, I'm just going to change these numbers as we go. So they told me that this was 2 times sine of 1/2 x minus pi over 3 minus 1. Like I said, we want to start with the midline. So we could draw a basic sinusoidal graph and use that as our beginnings. So we know that it goes up to 1, goes back down to pi, and then halfway through here it goes down to -1, and then back up to 2 pi. That's our original graph. And now we can move it. The first thing we do is shift the midline down to -1, -1. Straight read. Ba, 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 ba. Now we know where the middle of it's going to go. And we can also figure out where the limits are going to be because the amplitude is 2. So that means that the amplitude is going to be 2 up and 2 down from here. So I can draw another little line like that, saying that's the top of the graph, and the bottom of the graph, sorry, should label that, is at -3. So that just keeps going like that. So now I've got my parameters, I know where it's going to be. Now I pretty much just need to know where it starts at, so and how much it's going to be shifted by, and what my period looks like. So 2 pi over 1/2 is, I'll just do the work over here, 2 pi divided by 1/2, because we hate stacking fractions, is the same as 2 pi times 2. So it's going to actually be 4 pi. So that means that my whole wave is going to be out so that it's going to take up twice as much space that way. Now I can't anchor that yet because I have to use, let's let's see, I'm just gonna color code this a little bit. This was pink, this was red, and we haven't used this one yet. What we need to know is how it shifts this way or that way, so that we need to have an anchor point and then just move it pi over 3. So if I have this as my starting point, then I'm going to move it minus pi over 3, so negative pi over 3 that way. But this is on the midline, so it's actually going to go here. So I'm going to draw my wave with the brown pen. That's how I figure out my starting point. So I had to do it in 2 steps. I went, this was my starting point. It shifted over, but it was on the midline, so I have to drop it down to the midline. Now that's my new starting point. Now I know that that point goes there. And I know that that point isn't going to happen again until, so it should be, instead of, explain this carefully, instead of being pi from here to here, we've doubled this, so it should be 2 pi from here to here, which means that I'm going to bring this down and put it beyond there if there was a tick there. So now I've taken this, brought it down, stretched it double. So now I can use that and just follow the pattern halfway between here, just a rough sketch. Is going to go like that, and then it's going to continue on so that this would have gone down, well, we'll just go like that. So if we were to continue to draw this, we would have it going down to this line and continuing back up and so forth. So to recap, you have 4 pieces of information. You know what your basic graph is supposed to look like. You start there. You take your 4 pieces of information, starting with the vertical drop or rise, and change where your midline is. Once you know where your midline is, then you want to know where the outsides of the wave will be, and that is your amplitude. So in this case it was 2, we went up 2, that's our new amplitude. It was 1, now it's 2. It goes down 2 as well. So now we know what those parameters are. Then we want to check out the period and figure out how much it's going to be stretched, but we can't actually apply that until we figure out our horizontal shift, and minus goes that way. So we pick our original point, we move it whichever way it needs to go, and we put it on our midline. That's where we start. After that, we use the proportions of the wave to continue to draw the pattern until we're done.